we are going to be going over domain and range of graphs in this video. Sometimes this can be a little bit tricky, but I know it's something that all of you are capable of doing. So I think sometimes it just takes a little bit of extra practice. So that's what we're going to do in this video today. So hopefully help you understand how to find the domain and range from a graph a little bit better. Our first problem here is actually from the homework. You might recognize it. So here's a freebie answer for you if you have not done the homework yet. So what we're going to do, the whole point of finding the domain and the range is to think about what values in the graph that x can be and what values in the graph y can be. So domain is always the x values and range is always the y values. So this is important to know. It's also important to know that this horizontal axis is always the x and this vertical axis is always the y. So we first start off by looking at the domain. And the domain is always the x. So we are thinking about what values in this graph x can be. So I always start off with the smallest. What is the smallest number along the x-axis that I can have? So as I move to the left, my numbers get smaller and smaller and smaller. So I want to see how far can I go on this graph. Well, it ends here at -5 is my x. So for the domain, I would write -5 is less than or equal to x, because -5 is, it can be equal to -5, or x, it could be less than anything you have else for x. Now we're going to think about what is the biggest number you can have for x. So when we go to the right, the numbers get bigger. So which point on the graph is furthest to the right? So I look, and here I see it's furthest to the right. I go down and see that this is when x equals 3. Since I'm looking at the range, I'm only going to think about the x values. So since 3 is the biggest, I'm going to add it on here. So this inequality here, -5 is less than or equal to x, which is less than or equal to 3, tells us that x can be anywhere between -5 until +3. Any of the numbers in between work for the domain. Now let's look at the range. So the range, as I already said, is the y values. So now we are only going to pay attention to this vertical y-axis. We're not going to think about the horizontal x-axis anymore, only the y's. So just like the domain though, I start off by thinking, what is the smallest y value I can have? On the y-axis, when you go down, the numbers get smaller and smaller and smaller. So on our graph, what is the lowest point? And I can see the lowest point is right here. So I go over to my y-axis, since range is y, so we look at the y's, and I see that it is at -2. So -2 is the smallest y value that we can have. Now I will look to see what is the biggest y value. So as we go up, the numbers get bigger. So what is the furthest point up on this graph? Right here is the highest point. And I look to see the y, since we're talking about range, and the y is 4. So the biggest the y can be is 4. So our y values are going to be anywhere between -2 and +4. So anywhere in this region can be the range or the y values. And we write it with the inequalities to show that the y is in between those two numbers. Now here's another graph that we can look at. So once again, domain x, range y. So let's start off with the domain. So since it's our x values, we are only going to look at the x-axis here. Nothing else, only the x for the domain. So I start off by thinking, what is the lowest amount that I can have on my x-axis? So if I go this way, the numbers get smaller and smaller and smaller, and I keep going until I get to the furthest point to the left on this green graph here. And the furthest point to the left, the smallest along the x-axis, is right here. And this is when x equals 0. This is the 0 point right there. So 0 is less than or equal to x. Now let's see what is the biggest that x can be. So we'll keep going, bigger, 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 and it stops right there. Now you might notice there's something different in this graph, this end compared to this end. This end we have a point, and this end we have an arrow. This arrow is really important because it tells us that the graph, it doesn't just stop here like it does at this point, it's done. The graph points to the fact that this graph continues on forever and ever and ever. So I could, if I wanted to make a bigger graph, I could make this x-axis longer, and I could continue this line further and further and further and further, and it's just going to keep going and going and going and going. So the x values, even though on this graph we have drawn, it stops around 10, really because of the arrow, it tells us that it keeps going, going, going. So the x values that it's with just keep getting bigger and bigger. Like here, it might be when x is 12, 14, 16, 18. We keep going more and more, we'll get to like 100, 1,000,000, 1 trillion. They'll just keep getting bigger and bigger forever and ever and never stop. So to show that it keeps going forever and ever, we say that it goes until infinity. Infinity is the biggest that it will be because it never stops getting bigger. Now let's look at the range. So the range is the y values. So we are only going to look at this y-axis. So first, let's see what is the smallest that our y can be using this graph here. So remember, as we go down on the y-axis, we get smaller. So we'll keep going until we get to the smallest point on this graph, which is right here. It does not continue on, it stops right here. And so we look to see what is the y value at this point. So the y is 0. So 0 is less than or equal to y. Now let's see what is the biggest y value that we can have. So if you remember the graph, even though in our picture it stops here around 3-ish, really because of that arrow, it keeps going up, 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 up. So it's just going to be matching up with bigger and bigger and bigger y values, and it's never going to stop getting higher and higher and higher. So to show that it goes on forever and keeps getting bigger and bigger and bigger, we will say that it goes until infinity. The other thing that we can look at in this graph is it a function? So in order to tell if it's a function, I need to do the vertical line test. So the vertical line test is when I draw a vertical line at any place in the graph. It should only cross that green graph at one point. If it ever crosses any more, that means it's not a function. So no matter where I draw my vertical lines, it always only passes this green graph at one point, never more than one time. So because it passes the graph at one spot for every single vertical line, then we would say, yes, this is a function. Now let's look at this next graph. So once again, we can determine the domain and the range. So the domain would be the x values. So we are going to look first only at the x's here. So we're first going to see what is the smallest that x can be on this graph. We always start with the smallest, and when we write it, we go smallest to biggest. So first, smallest. Along the x-axis, what is the smallest that we have? So I'm noticing that along this graph, like right here, it goes with -2 for the x. Here it's -4, -6, -8. They just keep getting smaller and smaller the more I go in this direction. So we're getting smaller, and then you'll notice that here at the end we have an arrow. That arrow is telling us that even though it stops here in the picture, really it continues on forever and ever and ever and ever, just keeps going. So if we continue to go up, 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 over, 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 the x values are just going to keep getting smaller and smaller and smaller. And it goes on forever, it never stops. So to show that they just keep getting smaller and smaller and smaller forever and ever and ever and ever, we write it like this. Negative infinity is less than x. Now that we have the smallest, now we want to see what is the biggest that x can be. So I'm noticing that on the graph, the x values are getting bigger and bigger and bigger as we move along in this direction. And you'll also notice that this graph, or this side of the graph, also ends in an arrow, which tells us that it really continues on forever and ever and ever. So really, it's just going to keep getting bigger and bigger and bigger. So it goes all the way to positive infinity. So when we go from negative infinity to positive infinity, there are no numbers that are not included in that. From negative infinity to positive infinity, it includes every single number. So this is actually how we would write that. All real numbers. I would recommend first writing this inequality here. Then when you see you go from negative infinity to positive infinity, adding on all real numbers. Since literally any number that you put in, as long as it's not an imaginary number, any number you put in for x, if you go up, there will be a point on the graph there. Now the range is the y, so we are only going to pay attention to the y now. And our first step is to see what is the smallest that y can be. So I look to see what is the lowest point on the graph, since if we go lower, we get smaller. And I'm seeing that right here, this is the lowest that it can be. When x is -1, we are at our lowest point. But the thing is, we're not talking about x here. We're doing the range. The range is y. So -1 has nothing to do with this. This is just, it happens to be where the lowest point is. I want to know what is the y value at the lowest point, because range is y. So at this lowest point, I'm going to look over and see what the y value is at that point. And I see that when I go over to the y-axis, it's at 0. So our y value at the lowest point is 0. It does not go any lower than that on the y-axis, only until here. Now let's see what is the biggest that y can be. Well, I'm noticing that in this direction, it just is going to keep going up, 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 forever and ever and ever. Well, same thing here, up, 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 forever, ever, ever, and ever. So the number on the y-axis that it matches with is just going to keep getting bigger and bigger and bigger, higher and higher and higher, never stopping. Over here too, bigger, bigger, bigger. They're both matching with positive y's. So if it continues on forever and ever, we're going to write it goes until infinity. We can also check here to see if it is a function. And we do this by doing the vertical line test. So anywhere I draw a vertical line, doesn't matter where, it should only cross the graph at one point, which all of them do. They just cross the yellow graph at one place every single time. So that means yes, it is a function. Here is another example. So first, let's start off with the domain. So remember, the domain is the x values. So the first thing I'm going to do is see what is the smallest we can have on the x, and then what is the biggest we can have on the x. So first, smallest. Let's see what is the furthest to the left we go. And right here, and we have a point, we don't have an arrow, so that means it stops here. It does not continue on forever, just right there. And since we're talking about the domain, we're talking about the x's, so let's see what the x value is at that point. -9. So -9 is the smallest that x can be. Let's see what the biggest x could be. So we're going to keep going. This is the ending point on the graph, but notice that there is an arrow. The arrow tells us that this is going to continue going forever and ever and ever. It's never going to stop going down. So if we were to continue, make this graph even bigger, it would just match up with bigger and bigger and bigger x values, and it's going to keep going forever and ever and ever. So since it goes on forever and ever, we say it goes to infinity. You might be noticing that I'm using some different symbols. So like on this one here, I have less than or equal to. That's what this little line here means. So we have less than, this line means equal to. But then this one, I just have less than. I don't have the line underneath to show that it's also equal to. Here's the reason why. On our graph, x can exactly equal -9. We can be exactly at that point, so it can equal that. Or -9 can be less than many other x values. So we say it's equal to or less than. But infinity isn't really a number. It's just a way for us to say that it continues on forever. Like if we were counting, it wouldn't be like, I don't know, a million, one, infinity and one, infinity and two. It's not like that. Infinity isn't really a number. So it will never exactly equal infinity. So because of that, we do not write the line underneath to show that it's equal to. It will never equal infinity. So the rule is, if you have, on graphs like this that we're practicing right now, if you have a number, do the less than or equal to. But if you have infinity, just do the less than symbol, because it will never actually equal infinity. Anyway, let's move on now to the range. I'm going to move it up here since my graph kind of got in the way. So range is y. That means we're only going to look at the y values. So first we start off with the smallest y. So remember, as we go down, the y gets smaller and smaller. So what is the furthest down that we go on the y-axis? So the lowest point on the graph is here. This is the lowest. But remember, it continues on and on and on and on forever and ever and ever. So it's going to keep getting lower and lower and lower and lower and lower and not stop. And so since it goes lower and lower and lower forever and ever, we say negative infinity. Then since it's an infinity, we just write less than, or y. Now let's see what is the biggest that y could be. So the highest up point on this graph. Well, here's the highest point. There's not an arrow, it just stops here. So let's go over to see what our y value is at this point. Y is 2. And since we have a number, we'll write less than or equal to 2. Then the last thing is we decide if this is a function or not. So we check our vertical lines anywhere along here at any x. It should be crossing at only one point, which it is, which means that yes, it is a function. Okay, now for the next graph. So this graph is similar, but I guess kind of like the opposite. It goes on forever in this direction this time. So once again, let's start off with the domain. Domain is the x values. So first we will look only at the x-axis here. That's all we care about, where our graph matches up with the x-axis. So we always start with what is the smallest that x can be. Remember, as we move to the left, it gets smaller and smaller and smaller. So I want to see what is the furthest to the left that this graph gets. Well, this is where it ends here, but you'll notice there is an arrow. The arrow tells us that the graph really is continuing on and on and on forever and ever. So along the x-axis here, it's just going to keep getting smaller and smaller and smaller and smaller, and it's going to keep doing that forever. So to show that it goes on forever, we put negative infinity. Since it's infinity, we just write the less than symbol, x. Now let's see what is the biggest that x can be. So as we go along here, it gets bigger and bigger, and the furthest to the right spot is right here. And we'll look to see, since we're talking about domain, what is the x value here at this point, and the x value here is 0. So since it's a number, we'll do less than or equal to 0. Now let's take a look at the range. So the range is y. Now all we care about is the y-axis. So first, what is the smallest that y can be? The furthest down point. So remember, this point here, it's the smallest point on how we've drawn the graph, but it has the arrow, which means it keeps going down, 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 down. So it's going to keep decreasing on the y-axis, getting further and further down. And it continues on forever, so forever and ever it's going to keep getting lower and lower and lower. Since it keeps getting lower, we show that as negative infinity is less than y. Now let's see what is the biggest y can be, or the furthest up. Well, this is the highest point, and along the y, it's 0. So y is less than or equal to 0. And then the last thing is, let's see if this is a function. We can draw our vertical lines anywhere on the graph, any x value, and I'm seeing that it's not crossing the graph at 2 points anywhere. It's only crossing the graph at 1 point for every single vertical line. So that means that yes, it is a function. Alrighty, next problem. So we're going to first start off with the domain, which hopefully you remember at this point. Domain is the x values. So looking at our x-axis, this is the only thing we care about when we're talking about domain. Anything along here does not matter. We only care about the x when we're talking about domain. So the first thing is we need to figure out what is the smallest that x can be. So we need to take a look at our graph and see what are some of the x values we have. So like at this point, x is -1, -2, -3, -4. It just keeps getting smaller and smaller as we move along the graph. Our x values get smaller. And then you'll notice this graph also has an arrow, which means that really this is going to continue on and on and on forever and ever. So these higher up points are just going to keep matching with lower and lower numbers on the x-axis. So since it continues on forever and the x keeps getting smaller, we would say that the domain, the smallest, is negative infinity. Now let's look at what the biggest number x could be for our domain. So taking a look at the graph we have, I'm seeing that as we move along, the numbers on the x-axis that it matches with are getting bigger and bigger. Once again, we have an arrow, which means that the graph is going to keep going up and up and up and up. And so these points here are just going to keep matching up with bigger and bigger x values. So it's getting bigger and bigger. It's going to continue on forever. So that tells us it goes to positive infinity. Then if you remember, if we have something like this, where it goes from negative infinity to positive infinity, literally any single number will work, then we write it like this: all real numbers. Now the range. Range is y, so we're going to look at the y-axis. What is the smallest that y can be? This is the lowest point here. So we're going to think about what is the y value here, because we're talking about range is y, so we want to know what's the y value. This right here is when y equals 3. Now let's see what's the biggest that y can be. Well, both directions here, it just keeps going up, 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 up forever and ever. And if it keeps going up, it never stops. It's going to go to infinity. Last, is this a function? And yep, it passes the vertical line test. No matter where I draw vertical lines, it only crosses the orange graph at one place. So yes, it is a function. So this is what we went over today in class. If you were absent today, hopefully you kind of have an idea of what we did together in class. And if you were there and you just wanted a little bit of extra instruction, hopefully this helped you out, knowing what is the domain and what is the range of graphs that look like this, except I guess this is kind of messy at this point, but it's a lot of work that we did. So hopefully this helped you out. Of course, if you have questions, let me know and I'm happy to help you.